I'm going to talk about reflections in this lesson. Another name for reflections would be flip. So by definition, a reflection is a flip of a figure. It could be a point, it could be many different things, where you flip it over a point, a line, or a plane. Now the line of reflection is that line that we actually flip the figure over. And then an isometry is a congruence transformation. Now a reflection is a form of transformation, and we're going to learn about other transformations as we go through this chapter. The congruence part comes into where it says the figure you start with, once you transform it, the old figure and the new figure, the old figure referred to as the pre-image, the new one referred to as the image, they're congruent. And if that happens, you have an isometry. Now my first one I want to look at just reflecting a figure over the y-axis. Now what we need to know about a reflection is kind of the mathematical definition behind it. If you're going to reflect something over a line, the segment that would connect the pre-image, which would be I'm going to start with the green point, -3,7, to its image, wherever that's at, has to be perpendicular to your line of reflection. So what I've done here is I've just drawn in a line that's perpendicular to the y-axis. Y-axis is vertical, perpendicular to it is horizontal. Now the other part of it is the distance from the pre-image to the line of reflection has to be equal to the distance from the line of reflection to the image. Well, I count here of from -3,7 back to the y-axis is 3 units, so I'm going to have to go 3 units to the right to find my image, which turns out to be at 3,7. So the image of -3,7 is going to be a +3,7. If I go through and do the same thing for my red point, I'm going to create that perpendicular ray, in this case is what you'd look at it. And now I have to figure out how far the red point is from the y-axis. I count it, it's 5, so then I have to go 5 to the right to find my image, which is going to turn out to be at 5,3. Now it's not always going to have to go to the right. If my points would have been on the right side to start, the pre-image is on the right side, then I'd go to the left. So don't always think you're always going to go to the right. And then my last one at -2,1, I'm going to put in my segment that would be perpendicular to the line of reflection. And then it's 2 units away from the line of reflection, so my image has to be 2 units away, and that's at 2,1. Now hopefully you're seeing this little bit of a pattern form, or not a little bit of a pattern, but it is a pattern. We notice when we flip over the y-axis, the y values always stay the same. So my kind of little formula that I have down here of, if I start out at a point x, y, well my y values never change, so whatever the y value was is going to be the y value for the image. But what we notice about all the x values is went from -3 to +3, -5 to +5, -2 to +2. So my x value is going to be the opposite. Start off with x, it's going to end up at -x. Now realize that if I have a negative number to start at my pre-image, then the image will be positive. So that's flipping over the y-axis. Now if I go over and look at the x-axis, nothing really changes as far as the definition of a reflection. We still are going to have to flip it over. Now this time it's going to be the x-axis, but now my segment that I make is going to be a vertical one because it has to be perpendicular to the horizontal line of reflection in this case. Now how far is my green point away from the line of reflection? I could count it. It's 7 away, so then my image is going to have to be 7 away as well. It would end up right there. Now the coordinates there would be -3, -7. So the image this time, a little different than what it was last time. I can do the same thing for my red point, create that perpendicular segment, and then this one is 3 units away from the line of reflection. And now I'm at -5, -3. My purple point, suppose I should make my perpendicular segment first. And that one is 1 unit away. So I'm right there, which ends up being at -2, -1. And hopefully you're seeing a pattern form here. So if I take any point on the coordinate grid and flip it over the x-axis, what I notice is my x value was always the same as what it was to start, or is equal to it. My y value, on the other hand, that's the one that changed, and it just became whatever, or the opposite of it. If it would have been a negative to start, then it would have become a positive here. So, flip over the x-axis, the x value stays as is, the y value is just going to be the opposite of it. Now let's flip over a different line, a line y equals x. I'm going to do the same thing I did before. I'm going to have to make that perpendicular segment from my pre-image to where my image will end up at. Well, I'm going to look at my line y equals x. The slope of that is 1, so then the slope of the line perpendicular to it is going to have to be negative 1. I'm going to start at my point negative 3, 7, and I'm going to create a segment that has a slope of negative 1, which means I'm going to have to go down 1 and right 1, down 1, right 1. So if I continue to go down 1, right 1, my segment or ray or line, however you want to look at this, is going to look something like that. Now I have to find out how far it is away from my line of reflection. And what I'm going to do here is I'm just going to count diagonals. So if I start at negative 3, 7, 1 diagonal, 2 diagonals, 3 diagonals, 4 diagonals, it's 5 diagonals away. So then I have to go and I got to count 5 diagonals the other way. So 1, 2, 3, 4, and 5. And right there is my image. That point is at 7, negative 3. Do the same thing for my red point. I'm going to go down 1, right 1, and just keep going down 1, right 1 all the way through. So there's my perpendicular segment. Somewhere on that segment is my image. Well, this one is 1, 2, 3, 4 diagonals away. Count my 4 diagonals on the other side. I end up at the point 3, negative 5. Same thing with my purple point. Create the perpendicular segment here. Then I'm going to count my diagonals. Well, this one's a little different. 1, and I'm calling that a half. So I'm 1.5 diagonals, then I go 1.5 diagonals the other way. I end up at that point, and I am at 1, negative 2. And I guess I probably should have been this whole time drawing in my triangle. So here would be the triangle. And if you'd go back on your notes and put in all those triangles, connect the 3 points that we reflected, and now if you look at those triangles, you're going to realize that they're congruent to the pre-image. Little side note there, I guess. Now, look at the pattern here. Negative 3, 7 became 7, negative 3. It appears that my x and y just switched. If I go to negative 5, 3, yep, the x and the y just switched again. Same thing with my purple point. So what used to be a point of called xy, when you flip it or reflect it over y equals x, your image will become y comma x. Now if we flip over y equals negative x, I feel like a bit of a broken record, and I'm going to do the exact same thing again. I have to take my point and I have to create a segment perpendicular to the line of reflection, just like so for the green points, and then figure out, well, how far away is that point from the line of reflection. And again, I'm going to count diagonals. 1 diagonal, 2. So I go 1, 2 diagonals. There is my green point, which now is at, negative 7, 3. Same thing for my red point. Now I'm going to go this way. Now realize this time, the slope of my line of reflection is negative 1, so I'm making segments that have a slope of positive 1. Now my red point is 1 diagonal away, so I go 1 diagonal away, and I'm right there, and I end up at negative 3, 5. And then last, my purple point, make my perpendicular segment, look at this one, and I'm half, I call it half a diagonal away. Well, half a diagonal away puts me right there, which would be at negative 1, 2. On this one, if I put my triangle together, we're going to go from purple to red to green. And this one's going to be a little harder to see because they're overlapping, but what you'll look at and realize in that is that the pre-image triangle is congruent to the image triangle. And then when you look at the coordinates of the image, if we start out at x, y, we look at our point. So it looks like the x and the y are switching. So -3, well, but it becomes a +3. So yep, they change places. So we have our y and our x, but they also change signs when you flip over y equals -x. Now my last one would be, I'm going to reflect about the origin. This one has a little different concept, and you don't have that line to reflect over, so you can't make a segment that's perpendicular to your line of reflection. So what you do when you reflect about a point is you head, and I'm going to use more of a straight edge this time. I probably should have done it on the other ones. You are going to take your point and you are going to head towards, I call it, towards the point you're reflecting about. And then you're just going to keep going through that point using that same direction. So I went from my pre-image point, went through the origin in this case, because that's the point I'm reflecting about, and now I have to go that same distance away. Well, to figure this one out, what I do is I start at my point, -3,7, and I go, well, I went 3 back to the right to get to my point of reflection, and then I went down 7. So if I go, I'm going to have to go 3 to the right again, and then down 7, and notice I end up right there. Coordinates of that point, whoopsie, guess I don't have a pen out anymore. Coordinates of that point, like I was saying, are going to be at 3, -7. If I do the same thing for my red point, I'm going to head towards the origin and then keep going. Like that. And then again this one. Now on this one I have to go 5 to the right to get back to the origin and down 3. So if I go 5 to the right and down 3, I get my pre-image point here, which is going to be at 5, -3. And last but not least, my purple point, take my segment, head towards the origin, and then just keep going. It's a little harder to see because I have a lot of things going on now. But I can see on this one, I go 2 to the right, and down 1. So if I go 2 to the right, and down 1, I end up right there at that point, which is at 2, -1. I'll connect the dots here to make my triangle. And hopefully you can tell, and then I know we can't go by what it always looks like, but I'm going to tell you that your orange triangle here is, yes, in fact, congruent to the orange triangle over there. So the pre-image and the image are congruent here. And then finally, let's just figure out that little formula. If we started at x, y, where does it end up? Go back and I look at my different points. When I look at this, I see that my x values are pretty much staying in the same spot, or they are staying in the same spot, and so are my y's. However, -3 became a +3, -5 became a +5. What that's telling me is that that x value is changing its sign. And then when we look at the y values, notice all my y values in the pre-image were positive, all of them on the image were negative. Now, it's not always going to happen where they're always, or all the pre-images will be positive and all the images will be negative. They might change up a little bit. Some of them might be positive, some might be negative. But what does happen is, whatever you start with, whatever your point is, the x and the y value will just change their sign when you reflect about the origin. Now that's going to conclude the lesson. Oh, excuse me, it's not. I have 2 more slides in here. This one's going to talk lines of symmetry. What is a line of symmetry? It's really that line that you can flip something over and it lands on itself, or you can think of as if you actually had it cut out and folded it, that would be your fold line. So in the first one, I just got a couple little examples. How many lines of symmetry does the point F have? Well, I can't put a line anywhere in that and have it fold on top of itself or flip over on top of itself. So this one has 0 lines of symmetry. Now this next one's supposed to be an isosceles triangle. This one, I can put a line in right here, and if I flip it over that one, you're not going to be able to tell the difference between where I started and where I ended. So it would have 1 line of symmetry. And then my next one is the rectangle. Well, on this one, I can put in this line and flip it, and it would look the same. Same thing here. So that one has 2. Work my way down. This one is supposed to be an isosceles, or excuse me, an equilateral triangle. That one I can put in a line here, a line here, and a line here. So it has 3. Go to my square, that's what the next one is supposed to be. I can put one here, I can put one here, just like the rectangle. But in the square, you get to go diagonal and diagonal as well, because that will work. So we're up to 4. Go to the star. Now in the star, we're going to have multiples. I can put 1 in, and I don't know if this is the best color to use. 2, 3, 4, 5 lines of symmetry into that star. So it's one of those things where you just got to look at it and draw them in and ask yourself, well, if I fold it there, will it fold on top of itself? Or if I flip it there, will I be able to tell the difference between the pre-image and the image? And then my last one is just point of symmetry. What is a point of symmetry? It is that common point of reflection, or it's the center of the figure. Actually, it's both of them. So what I like to do is I like to take my figure and draw in all the lines of symmetry. If all the lines of symmetry intersect at one point, point of symmetry. I have my other one over here. All my lines of symmetry intersect right here, point of symmetry. So then my little examples, do these figures have points of symmetry? Well, I go to my capital letter B, I can put in 1 line of symmetry, but that's it, so this one does not have any points of symmetry. If I go to this hexagon, it appears I could put in a line of symmetry there, in the line of symmetry there. Therefore, yes, I have a point of symmetry on this one. And then my capital letter H, I could put in a line of symmetry here, I could put in a line of symmetry here. I could put this one in too, I believe. Yep. And this one. Now notice they all intersect at one point. So that one also has a point of symmetry. That's where I'm going to conclude my lesson on reflections.